All right, let's start the second derivative test. So I copied down our first derivative before we did the double angle change here, because I think this is just a little bit easier to take the derivative of. The other one's not bad. It require the product rule, which is fine, but I'm going to choose to stay here. Okay. So the derivative of negative 2 sine theta, just a constant times the derivative of sine, no big deal. The derivative of 2 sine 2 theta requires a chain rule, so I'm going to go ahead and state my inside and my outside. So the inside function is 2 theta, right? This is what's inside the sine function. So the outside function, I'm going to pick 2 sine x here. I'm going to go ahead and let that constant be part of that outside function. So then the derivative of the outside, the derivative of 2 times sine x is 2 times cosine x, right? Because we're just going to get the constant times the derivative of the function. And then the derivative inside is 2 again, right? So I'm going to plug b into a prime, multiply times b prime. So I'm going to get 2 cosine 2 theta times the derivative of b. So I'm going to get 4 cosine 2 theta. All right. So the second derivative here, the derivative of sine is cosine. So I'm going to get negative 2 cosine theta plus 4 cosine 2 theta. All right, so again, we have a single angle and we have a double angle. And so we need to do a trig substitution. Cosine 2 theta has 3 different trig substitutions. And so I just remember the first one right offhand at the moment. The double angle is cosine squared theta minus sine squared theta. But I can get the other two by just doing, a Pythagorean substitution. The one I want is the one that has only cosine in it, because this term has a cosine. I don't want to use a formula that has sine in it. So I'm going to replace sine squared with 1 minus cosine squared. So I'm going to get cosine squared theta minus 1 minus cosine squared theta. And that's going to give me minus 1 plus cosine. So I'm going to get 2 cosine squared theta minus 1. This is the one I'm going to use here. Okay. So cosine 2 theta is really 2 cosine squared minus 1. Right? So I'm going to make that substitution. Oh, and I'm going to set it equal to 0. So I'm going to get negative 2 cosine theta plus 4 times 2 cosine squared theta minus 1 equals 0. Right? This one's quadratic. This is fun. Here we go. I'm going to go ahead and distribute the 4. So we get negative 2 cosine theta plus 8 cosine squared theta minus 4 equals 0. Right. I'm going to put this in descending order with the squared term first, then the linear term, then the constant. So we're looking at 8 cosine squared theta minus 2 cosine theta minus 4 equals 0. So I guess I could, take a 2 out. Let's go ahead and do that. Right? So if I take a 2 out, we're left with 4 cosine squared theta minus cosine theta minus 2. Right? And so it would be nice if this factored, but it doesn't look like it because we'd have to multiply to negative 8 and add to negative 1. So the only choice we have here is to use the quadratic formula. So usually you have x equals the quadratic formula. This time we have cosine theta equals the quadratic formula. Okay? And what happens to this 2? If you set 2 equal to 0, you get no solution. So it kind of just cancels off. Okay? It doesn't lead us to any critical numbers. So I think what I'm going to do is I'm going to go ahead and use my my quadratic formula on my calculator, and I'm going to get my 2 answers for cosine theta. So here we go. You guys should have this too, right? Program, quad. My A is 4, 4, my B is -1, and my C is -2, and I get 0.843 and -0.593. So just rounding to 2 decimal places, I'm going to use 0.84 and -0.59. Okay, so cosine theta equals 0.84 and cosine theta equals -0.59. Right? I can go ahead and cosine inverse this to solve for theta. Okay, both of these. And then I'm going to use the unit circle just like I did last time to find those secondary angles. Okay, so the first angle, if I cosine inverse both sides here, I'm going to get theta is whatever cosine inverse of 0.84 is. So let's go ahead and do that. Cosine inverse of 0.84 is an angle measure of 0.57. So theta equals 0.57. So on the unit circle, right, if this is 0 and this is 1.57, this is like a third of that, right? So it's kind of like a little angle here. And this little angle has an x coordinate of 0.84, and it has some y coordinate that we don't worry about. Okay, but where else is the x value equal to 0.84? Okay, the x value is equal to 0.84 below the x-axis as well, right? This is also 0.84 comma some y value. So the angle is 0.57 both times. So we can go, 0.57 around, or we can go all the way around 6.24 less 0.57. So my secondary angle here, we're going to do 6.28 minus 0.57 to get that other angle. 6.28 minus 0.57 gets us 5.71. Okay. This is my other solution on that restricted domain. Right? These are between 0 and 6.28. All right, let's do the other one. Cosine of theta is -0.59. So I am going to cosine inverse both sides to get that first angle. Okay, so if I do cosine inverse of -0.59, I get an angle 2.20. So theta equals angle 2.20. Where is that? So this is 0, this is 1.57, this is 3.14. Okay, so 2.20 is like here-ish, right? This is 2.20. Okay, and this point on the unit circle has an x value, -0.59, comma some y. Right, so where else is the x value -0.59? Well, it's down here in quadrant 3, right? This is going to be -0.59, comma y as well, right? So we can go 2.20 this way, or we could figure out what this reference angle is here, which is what I'm going to do, okay? So we went 2.2, so if I do 3.14 minus 2.2, that'll get me that angle there. 3.14 minus 2.2 gives me 0.94, okay, which means this angle is 0.94 past 3.14, so I'm going to do 3.14 plus 0.94, and that's going to get me 4.08. That's my other critical number, okay, that's my other solution from 0 to 6.28. So again, I have 4 critical numbers. So I'm going to do my number line analysis here. Starting at 0, 0.57, 2.20, 4.08, 5.71, and then end this at 6.28. So we're not going to go past this mark here, okay, or past here. So again, we have 1, 2, 3, 4, 5 intervals here. So I need to pick a test point for each interval. So I'm just going to pick half. A test point from 0.57 to 2.2, I'm going to pick 1. A test point from 2.2 to 4.08, I'm going to pick 3. A test point from 4.08 to 5.71, I'm going to pick 5. And then a test point from 5.71 to 6.28, I'm going to pick 6. Okay, so I'm going to go ahead and use my second derivative into the calculator and the table again to figure out where it's positive and where it's negative. So I am going to opt to use our original second derivative here, negative 2 cosine theta, or x, plus 4 cosine 2x here. And then go to the table and plug in those test points. 0.5 is a positive. 1 is negative. 3 is positive. 5 is negative. 6 is positive. Okay. So it's going plus, minus, plus, minus, plus. But this is the second derivative. So if the second derivative is positive, then the original function's concave up. And if the second derivative is negative, then the original function is concave down, right? So I have concave up from 0 to 0.57 union 2.20 to 4.08 union 5.71 to 6.28. Concave down 0.57 to 2.20 union 4.08 to 5.71, right? And then if it changes concavity, then we know that's an inflection point. So we have an inflection point at 0.57, f of 0.57, so you can plug that into your calculator to find the y value. Another critical or inflection point at 2.20, f of 2.20, 4.08, and 5.71. Those are all my critical numbers, right? And we could plug those in. If you have to find the y value, just plug them into your function and round it correctly. All right, I can hear your virtual moans. It's nice not to have to see you moan. That allowed me to kind of push my way through this example, but hopefully this will help you complete number 6 on the homework, at least give you a fighting chance. All right, I'll be available tomorrow night, you guys. I think I scheduled you at 6 Mountain Time, so I hope you can join in and I can work problems here on the Elmo because I can share my screen with you in that Zoom app. So please join me tomorrow night starting at 6 at any time, and I'll be here for you from 6 to 7 Mountain Time. All right, take care, guys.